Hey everyone and welcome. Today we are diving deep into something most of us use every single day, but probably don't think too much about: Wi-Fi security. We're going to trace the journey from the standard that protected us for over a decade, WPA2, to its seriously upgraded successor, WPA3. Trust me, the reasons for the change and what it means for you are pretty fascinating.
Just think about it for a second. Every single thing you do online over Wi-Fi, your messages, your emails, your banking, it's all protected by this invisible shield of encryption. For a really long time, that shield was called WPA2. And you know what? It was a fantastic guardian. But as time went on and hackers got a whole lot smarter, that once impenetrable shield, well, it started to show some pretty serious cracks.
Okay, I get it. The moment you hear words like cryptography and authentication protocols, it can sound super complicated, right? But don't you worry, we're going to break all of this down into really simple, easy-to-understand chunks. My goal here is to make this totally clear for everybody. And hey, if you like that kind of approach, definitely think about subscribing for more explainers just like this one.
So here's our game plan for today. First, we'll look back at the old champ, WPA2, and see why it was the king for so long. Then, we'll get into the juicy part, the cracks that started to appear. After that, we're all about WPA3, our modern defense, including its brand new secret handshake. We'll even unpack the magic of something called forward secrecy. And finally, we'll see how the world is actually making the switch without everything breaking.
All right, let's start with the one we all know, even if we don't realize it. For the better part of 2 decades, WPA2 was the absolute backbone of wireless security. It was the gold standard, period. And this timeline really puts its long life into perspective. I mean, 2004. That is an eternity in the tech world. It had an amazing run. But then 2017 happened. The discovery of the crack vulnerability was a massive wake-up call. It was the event that really lit a fire under everyone, leading directly to WPA3's introduction just a year later, and its mandatory adoption for new gear in 2020.
And that brings us to the core of the problem. After all those years of keeping us safe, some really serious cracks started showing up in WPA2's armor. The industry had no choice but to build something new.
The most famous, or maybe infamous, of these vulnerabilities is the crack attack. Now, this wasn't some minor bug. This was a deep, fundamental flaw in how the WPA2 protocol was designed. And the scary part? It meant an attacker, who just had to be physically near you, could potentially read your supposedly secure, encrypted information.
So how in the world did it work? Well, it took advantage of WPA2's connection process, the four-way handshake. The real weakness was in step 3. An attacker could basically trick your device into reinstalling the same encryption key it had just created. Every time that happened, it reset some important security nonces back to 0, which basically opened up a tiny window for an attacker to decrypt your data and spy on what you were doing. So, to sum it up, WPA2 had some major weak spots. First, crack made eavesdropping possible. Second, it was wide open to what are called offline dictionary attacks. That's where a hacker could grab your connection data and then use powerful computers to guess your password later, without you even knowing. And finally, it was missing a critical feature called forward secrecy, a really cool idea we're about to get into that protects your past secrets.
It was pretty clear that we needed a new shield. So enter WPA3, designed from the ground up to slam the door on these old problems and protect us from the kinds of attacks we face today.
And this quote just nails it. WPA3 isn't just WPA2 with a few patches slapped on. It's a complete rethink. It fundamentally changes how our devices talk to a Wi-Fi router, specifically to shut down those big vulnerabilities like crack and those offline password guessing attacks. Okay, let's get into the first huge upgrade. This one is all about our home networks. WPA3 gives us a brand new way to connect, a totally new and much more secure secret handshake. This comparison shows the difference perfectly. With WPA2, an attacker could just sniff that initial handshake out of the air and then go offline to try and crack your password with brute force. WPA3 throws that whole method out the window. It uses something called SAE, or Simultaneous Authentication of Equals. This new handshake is specifically built to kill those offline attacks, which means even a relatively weak password is much, much safer. The real magic here in the Dragonfly handshake is that your phone and your router can prove to each other they both know the password without ever exchanging any information that an eavesdropper could use to figure it out. This completely flips the script on attackers. They can't just sit there and listen anymore. To make just one single guess at your password, they have to actively engage with the network, which is super slow and makes them really easy to detect and block. All right,
The second game-changing feature in WPA3 is a concept called forward secrecy. And this is some really powerful stuff that adds a whole new dimension of protection to your data.
To get what forward secrecy is all about, you first have to solve a little puzzle. Imagine you and a friend are in a loud, crowded room. How could you both agree on a secret password or key when everyone around you can hear every word you say? It sounds impossible, right? Well, the solution comes from a really clever idea that's been around for decades.
And here it is, the Diffie Helman key exchange, explained with a super simple analogy using paint. Alice and Bob start by agreeing out loud on a common color, yellow. Then they each secretly add their own private color. Then they swap their new mixed colors publicly. Now anyone watching sees them swap orange and light blue paint, but because it's really hard to unmix paint, they can't figure out the secret colors. But here's the magic. When they each add their own secret color to the mix they just got, they both end up with the exact same secret shade of brown. They just created a shared secret right out in the open.
And that amazing little trick is what makes forward secrecy possible. By using a method just like that for every single time you connect, WPA3 makes sure that every session has its own unique temporary key. So here's the bottom line. Even if a hacker somehow steals your main Wi-Fi password a year from now, they can't use it to decrypt all the stuff you did in the past. Your history is safe because each session was locked with a different key that has long since disappeared.
And what's really incredible is that WPA3 brings this same level of security to those sketchy open Wi-Fi networks you find at coffee shops and airports. It uses something called opportunistic wireless encryption, which basically creates a private encrypted tunnel just for you, automatically, even without a password. It's a huge step up for public Wi-Fi safety.
Okay, so WPA3 is obviously way more secure. But how do you get the entire planet to switch over without causing total chaos? Well, the rollout plan is actually really smart. See, WPA3 isn't just one thing. It's a family of security modes for different needs. We've talked about WPA3 Personal for home. There's also WPA3 Enterprise for big companies, with even beefier crypto options. We just mentioned Enhanced Open for public spots. And then there's the unsung hero of this whole story, Transition Mode. Transition Mode is the secret sauce that makes this whole upgrade possible. It lets a router broadcast one Wi-Fi network name that both old WPA2 devices and new WPA3 devices can connect to at the same time. So your brand new phone gets the top-tier security of WPA3, but your old smart speaker can still connect just fine using WPA2. It lets everyone upgrade at their own pace. And that really brings us to the big picture here. The jump from WPA2 to WPA3 wasn't just a minor update. It was a critical evolution, a response to a world that's more connected and, frankly, more dangerous than ever before. It's a shield that's finally smart enough to keep up with the times. Thanks so much for